Well, by no means have I been alone. There's been lots and lots of people working on this, and any success I've had, they've had just as much. So I have my colleagues on the scientific end and the clinical end to thank for that, as well as our veterinary researchers as well. That said, the difficulty we ran into early on in this process was we didn't have the ability to quantify or control our final product. So we would process a sample, whether it was blood or a bone marrow sample, and we would concentrate that sample and we would implant it in the patient without having any ability to manipulate it or even understand what was in it. And I always joke that there aren't too many areas of medicine where we would implant something into someone and have no idea what was in it. We got away with it because it was the patient's own tissue, so the safety margin was very good. The risk was very low, but it wasn't good enough in my opinion. And we're talking '06 now, in 2006. So what I did was to create a platform where our first task was to figure out how to understand what was in it. So it was what we call a hemoanalytic platform. So we had to investigate technologies and processing protocols where we could first understand what was in it, which we did successfully. Then once we learned how to measure it, we had to validate it, meaning what we're measuring was accurate. So that involved lots of work to ensure that the measurements we were taking were correct. And that's a lot of basic science work and a lot of proficiency testing and quality testing. And we had to create something that didn't exist. So then once we figured out how to measure, once we figured out that what we were measuring was accurate, then we wanted to start to be able to control the final product, take different cell populations and isolate them, or change the platelet concentration in a PRP, remove the white blood cell content from the PRP and just use the platelets, add the white cells, do different things to the products which would allow us to either make them indication specific. For example, for an ACL you do this, for a muscle you do something different, for arthritis you do something different. We were creeping towards that pathway of precision medicine. So not only understanding the patient's physiology from a cell perspective, but controlling it and then using it to our advantage. So what I did in a lot of my work over the past 6-7 years has been creating standardization and quality control over the biologics such that we could improve the quality of our research, and then most importantly improve, once we learn from that, the quality of the implant that we're putting into the patient in the hopes of ensuring the best chance for success.